Hi, today I'm going to show you how to break into a machine called Mercury, which you can download from Vulnhub, and I'll put the link in the description. The aim of this video is not just to give you the commands to find both flags, but to explain each and every step along the way so that you can apply what you learn here to future machines. My goal is to create a whole series of these videos covering different machines and to help people learn by doing. Let's get started. The first step is to identify the IP address of our target machine. We can do this by using the command ifconfig, which will show our host machine's network settings. We can see that our host machine has an IP address of 10.0.2.15 and a subnet mask of 255.255.255.0. This means that the network portion of our address is 10.0.2, and so our target machine will be 10.0.2.something. To search for all hosts that fit within that range, we can use a tool called Nmap. Nmap is a network scanner and a commonly used tool within pen testing. It can be used to scan for hosts on a network, port scanning, host and operating system discovery, as well as a wide range of other uses. The command line takes the form nmap, space, any options we might want, space, and the target of our scan. In this case, we're going to use nmap, space, -sn as our option, 10.0.2.1 to 254 as our target range to be scanned. The -sn option tells Nmap that we aren't interested in scanning for open ports at this stage. We are only looking for hosts that are connected to the network. If we left that -sn out, Nmap would also scan for any open ports on each of the hosts it identifies. On our system, that would be fine, but if you are scanning a large network with hundreds of hosts, then disabling the port scan will save you time. If we look at the results of our Nmap scan, we can see three hosts. 10.0.2.1 is the default gateway. 10.0.2.15 is our host machine, so 10.0.2.9 must be our target machine. Now that we have our target IP, we want to run a port scan to see what ports might be open, and potentially give ourselves a way in. Once again, we're going to use Nmap. This time, we're going to use the command nmap, space, -p space, -A, space, 10.0.2.9. The P option tells Nmap to scan every port from 1 to 65,535, because by default it will only scan from 1 to 1000. The A option tells Nmap to also scan for additional information about devices, their versions, and the operating systems being used. We can see from the results of our scan that our target machine has two open ports, port 22, which is an SSH port, and port 8080, which is an HTTP proxy. SSH is the Secure Shell Protocol and is used to securely connect to a remote network. An HTTP proxy acts as an intermediary between the client browser and the destination web server. Given that we have two ports open, we have two options going forward. We can attempt to use SSH to remote login into the target machine. Unfortunately, we don't have any credentials yet, so that doesn't seem like a good option. We could also look more closely at this web server to see if we can find anything useful. The easiest way to start is simply to use a web browser to access the page and see if there is anything in there. Let's open our web browser and go to 10.0.2.9:8080. Unfortunately, all we get is a message that says, "Hello, this site is currently in development, please check back later." We can check the page source, but that also doesn't give us anything to work with this time. The next thing we are going to try is directory enumeration. Directory enumeration is a technique to find and list all the directories and files, and is a good way of uncovering useful information such as configuration files, database backups, and user credentials. There are lots of tools available for directory enumeration, and I'm going to show you two different ones here. The first is Derb. Derb comes pre-installed on Kali Linux and does a good job of finding web objects. We can run Derb using the command form of derb, space, target address, space, word list options, space, options. We can leave the word list options blank and Derb will use its default word list. Let's run Derb against our target machine. We use the command derb space http://10.0.2.9:8080. We are happy with the default word list and we don't want to add any special options, so that's fine as it is. We see that Derb has uncovered a file called robots.txt. If we open that up, we can see two lines of text. Line 1 has user agent and an asterisk, and line 2 has disallow and a /. A robots.txt file is a file that tells web robots, typically search engine robots, how to crawl pages on their website. In our case, we have user agent asterisk. The asterisk is a wildcard and refers to all agents. The disallow is followed by a /. The / denotes the root folder. In other words, this robots.txt file is telling all web crawlers not to crawl any pages on their web server. The reason robots.txt files are interesting to us is because they often give clues to restricted or private directories that can be exploited. In this case, it doesn't give us a whole lot, so let's go back and try a different tool. We're going to try using a program called FerrixBuster. I like FerrixBuster as it's powerful, easy to use, and I like the way it generates its output, but it does tend to be a bit slower than something like Derb. We're going to use the command FerrixBuster space -u space http ://10.0.2.9:8080. Once that's done, we can see that it's uncovered some directories for us. If we open these links, we reach an error page. It tells us that Django, which is a Python-based web framework, tried to match the URL we gave it to an index path, the robot.txt path that we looked at earlier, and a directory called Mercury facts. Because the URL we provided didn't match any of these, the request failed. The good news is that this error has provided us with a new URL to try. If we try to access our web page at this new directory, it takes us to a web page with a picture of Mercury and a couple of links. If we click on Load a Fact, it takes us to a new page with a fact about Mercury. If we click on See List, it takes us to another page with a list of tasks for the web developer to complete. These tasks give us a clue as to what to do next. The second line suggests that there exist user tables, which might give us some login credentials. The third line tells us that the databases can be interacted with using raw SQL inquiries rather than through the object relational mappings provided by Django. You don't really need to know what any of that means for our purposes today, except to know that it tells us that this web server is using databases that can be interacted with directly using SQL commands, and that there is likely to be a table of users somewhere in there. We are going to search for those databases using a tool called SQL Map. SQL Map is an incredibly powerful tool that automates SQL injection and can be used to take over databases. It can be run using the command form SQL space mandatory argument space target space additional options. In our case, we are going to use the command SQL Map space -u space http ://10.0.2.9:8080 /Mercury facts /space _dbs space _batch. The U command tells SQL Map that we're going to give it a URL as a target. The dbs command tells it we want to enumerate databases, and the batch command tells it to use default responses rather than asking us to input anything. We can see that our search has turned up two databases, one called Information Schema and the other called Mercury. Now that we have a specific database we want to search, let's use SQL Map again and see what we can find. This time, we will use the command SQL Map space -u space our target address space -D space Mercury space _dump all space _batch. The capital D tells SQL Map that we are going to give it the name of a specific database, in this case, Mercury. The dump all command tells it to output its results so that we can see what it finds. We can see that SQL Map has found two tables within the Mercury database. One contains some facts about Mercury, and the other contains a list of username and passwords. The next thing for us to try is to remote login using these credentials. We can try each of these credentials in turn by using the command SSH space user@target IP and then entering the password. So let's try each one in turn. We find that the user webmaster has the correct credentials, and we are now logged into the target system. The first thing we want to do is to see what files are available to us. We can use the list command, ls, to show available files and directories. I like to use the -all option because it gives me a little bit more information about permissions, modification date, file author, etc. we can see a text file called user flag. If we read it using the cat command, we see that it contains our user flag. So now we have our user flag, which proves we have user access to the target system. But to complete the challenge, we need root access to the system. If we look at our list of files, we can see a directory called Mercury_proj. Let's navigate to it using the change directory command, which is just cd followed by the name of the directory. If we ls all again, we find a text file called notes. We can once again read it with the cat command. It appears to be credentials for two users, Webmaster and Linux Master. Unfortunately, the passwords are not in plain text, but rather they are encoded using base64. Base64 is a method of transferring binary to text, but it's simple enough for us to decode it into plain text. Let's use the command echo space our text string space pipe function space base64 space ~decode. Echo is used to display the output of arguments as text. In this case, we're telling the system to output that text string once it has been decoded using base64. We see that when we copy in the string for Webmaster, it matches the login credentials we found in the database. When we decode the password for Linux Master, we find the plain text is Mercury mean diameter is 4,880 kilometers. Let's SSH onto the target machine using our new credentials for the Linux Master user. Next, we want to see what sort of permissions we have, so we're going to use the sudo-l command. This will list off everything we have permission to run with root permissions. We can see that the current user has root privileges for the check syslog.sh script. You'll notice that the script is running in a preserved environment, which we can see from the setenv command. This means that the environment variables from this command are carried over to any new commands or processes. In other words, we can set up environmental variables now, and then when we run the script later, those variables will still be in place. Right now, the only thing we can do as root is run that script, which doesn't do us any good. By setting up environmental variables, we can change what we are able to do as root. Let's take a look at what's in the script using our cat command. The script is running the tail program, which is a way of displaying the last 10 entries of a file, and it is doing that for the syslog. So, we have the ability to run tail as sudo, but that doesn't help, so we need to tell the system to run something else as root. We can do this by creating a symbolic link between tail and a program of our choice. In this case, we will use vi, a text editor, which we can then use to create a shell. We can create this symbolic link with the ln space -s /user/bin/vi space tail command. What this does is it tells the system that when we run tail from our local directory, use vi instead. The problem is that when we run that script, it won't be looking in our local directory, and it will find the real version of tail and not the one we've just set up. To get around this, we need to tell the system to look in our local directory first. We can do this by using the command export space path equals value bracket pwd close bracket semicolon value path. The export is telling the system to save this value and use it in future. The path equals value bracket pwd close bracket tells the system to search the current working directory first, and the value path tells the system to then continue along the default path. Now we are ready to run our script. We can do this using the command sudo space ~preserve-env equals path space /user/bin/check_syslog.sh. This tells the system to run the check syslog script as sudo, but using the path we've just given it, which will run vi instead of tail. We are now running vi as sudo. From here, it's easy to make ourselves a shell using the command :bin/bash. Now we have a root shell. We are free to do whatever we like. Let's change to the root directory using the cd command. We can use ls to take a look and find the root flag.txt. Use cat to read it, and there you have the root flag. So, in general terms, what we did to attack this machine was search the network to identify the target machine, scan for any open ports, enumerated the web directories, searched for databases and user credentials within those databases, logged into the target machine as a user, and then found a way to escalate our privileges to root level. I know that I spend a lot of time explaining what's going on here, but my aim is for you to understand why you are doing each step and not just giving you the commands to find the flag. One of the biggest issues I had following walkthroughs and learning this stuff was not understanding why I was doing each step or how it was helpful, so I decided to make these videos as the style of tutorial I would like to have had. I hope it helps, and good luck in your future hacking exploits.